All right, so we're going to finish up this packet, and we're going to go ahead and do pages 33 through 35. So starting on number 1, you push a car with a force of 930 newtons, a distance of 15 meters in 20 seconds. So I have force, distance, and time. How much work do you do? So remember, work equals force times distance. So force is going to be 930 newtons times distance, which is 15 meters. Multiply those out, and you get 13,950 joules. So there's your answer for part A. Part B, it says how much power do we generate? So remember, power is work divided by time. So I'm going to take that work I just found, which was 13,950 joules, divide it by my time, which is 20 seconds, and I get 697.5 watts. Okay, so remember, the power for the unit for power is watts. Okay, 2, Susie working at Kroger lists a 5 Newton bag. So remember, 5 newtons is the same thing as saying mass times gravity. So we just did some work for you and just gave you what those were. Okay, if she lifts the bag 1 meter in 5 seconds, how much work does Susie do? So remember, we're lifting something. So remember, work equals, so we're lifting, so mass times gravity times distance. Now in this case, I gave you mass times gravity. I told you that was 5 newtons. So this is just going to be 5. Okay, so you don't need to multiply 5 times 9.8 because mass times gravity is 5 newtons. And then my distance was 1 meter. Okay, so multiply that. So 5 times 1 gives me 5 joules of work. How much power does she generate? So remember, power is work divided by time. So my work was 5 joules divided by my time, which is 0.5. And I'm going to get 10 watts. How much potential energy did the bag gain when Susie lifted it up? So remember, potential energy equals mass times gravity times height. Well, in this case, if you notice, it pretty much looks the same as work here, which makes sense because we had to perform that work. We had to exert that energy to get it to that potential height, or that potential energy, or that height. So mass times gravity is 5 times my height, which is 1 still. So it's just going to be the same answer as part A, so 5 joules. 3, a roller coaster coasts down the hill as shown. Next to each number, fill in the appropriate size as shown below of potential energy and kinetic energy. Okay, so what basically we're doing is when it's bigger, we'll write it bigger. Whenever it's smaller, we'll write it smaller, or it'll be 0. So at 1, okay, we haven't started going down the hill yet. So that means my potential energy is high, my kinetic energy is going to be 0. So it's going to have a lot of potential energy, so I'm going to draw that bigger. As we go down, potential energy is going to get smaller. Okay, that means kinetic energy is going to start building up. So it's still going to be small, okay, but not near the potential energy size. Okay, and then as we keep going down, potential energy is going to get smaller, and kinetic energy is going to get bigger. Okay, and then when we get to the bottom, potential energy is going to top out at 0, so there's nothing there. And then kinetic energy is going to be the biggest at the bottom because that's when you have the most velocity. So as the roller coaster falls, its kinetic energy increases because remember, your velocity is increasing, but your potential energy decreases because your height. Okay, so we are losing height, which affects your potential energy, and gaining speed or velocity, which will affect your kinetic energy. Number 4, if the roller coaster has a mass of 500 kilograms and the hill is 30 meters high, how much work does gravity do on the coaster? Okay, so remember, our work is also going to equal out to our potential energy because we're talking about the top of the hill, which equals mass times gravity times height. So my mass is 500, gravity is 9.8, and then height is going to be 30. So multiply those out, and I get 147,000 joules. Okay, moving on to the next one. So number 1, a 15 kilogram mass. Okay, so I have mass with a speed of 10 meters per second. So I have velocity. Calculate the kinetic energy. So kinetic energy equals 1/2 mv squared. So 1/2 my mass, which is 15. My velocity is 10, and that is squared. So that's going to equal out to 750 joules. 2, an 8 kilogram bag of oranges drops a distance of 12 meters. What is the kinetic energy just before it strikes the ground? Okay, so what this means is whenever you have 2 different heights here. So remember, we have 2 different heights. You have when it's at the top. So you have this orange right here, and it's going to drop. and it's going to hit the ground. So when it's at the top, all it has is potential energy. Okay, kinetic energy is 0. It hasn't stopped falling yet. And then whenever it hits the ground, potential energy is gone. And then, and kinetic energy is all that's left. So remember, what we can do is we can do PE equals KE. Okay, so remember, kinetic energy is gone up here because we're not even moving. And then down here, potential energy is gone because we have no height. So we can set those equal to each other. So MGH equals 1/2 mv squared. So remember this trick, if mass is on both sides, you can set those equal to each other. Okay. Now, in this case, we're not looking for velocity, anything like that. We're just looking for what is the kinetic energy when it reaches the ground. But this will kind of help you when you get actually into solving stuff. But in this case, all we wanted to know was what was the kinetic energy when it hits the ground. Well, if we can find potential energy when it's at the top, okay, our potential energy is going to be mass times gravity times height, so 8 times 9.8 times my height, which is 12 meters. And that's going to come out to be 940.8 joules. Now, remember, conservation of energy means we don't lose energy. So if my total energy at the top was 940.8 joules, when it hits the bottom, it's going to be 940.8 joules. So this also equals the kinetic energy at the bottom. So that's your answer right there. 3, a 4 kilogram case of kidney beans drops 5 meters. What was the potential energy of the case of beans at its highest point? Does everyone have to have the same answer to this question? Okay, so as far as that question goes, if you take mass out, it kind of will affect it there, but for the most part, I'm going to show you the way I do it. So we should have the kind of the same answer here. Just I don't want to create any confusion. So if we want to find potential energy, so remember potential energy equals mass, which is 4, times gravity, which is 9.8, times my height, which is 5. And that comes out to be 196 joules. B, what is the kinetic energy of the case just before it hits the ground? So remember we said if potential energy, before you dropped it, this is the total energy you have. And it's all potential. That means we do not lose that total energy at all. Okay, it can convert between potential and kinetic. But when I hit the ground, you are purely kinetic. So that means if I had 196 joules in the beginning, there better be 196 joules in the end. It's just now kinetic. C, what speed do the beans hit the ground? Okay, so I can take that kinetic energy, so I can bring it down here. So 196 equals 1/2 mv squared, so my mass is 4. Velocity, I don't know, leave it as v. So get v by itself and square root both sides, and you get 9.9 meters per second. 4, a roller coaster has a mass of 3,000 kilograms. It proceeds from point A to point B through the loop and then to point C. What is the potential energy of the coaster at point C? So at point C, we're talking about right here. Okay, potential energy is mass times gravity times height. So potential energy equals my mass, which is 3,000, gravity, which is 9.8, and my height was 15 meters. So that comes out to be 441,000 joules. Okay. Part B, it says how much PG did the car lose while going from point A to point C? I want to know how much potential energy did I lose. So we need to figure out what is the potential energy at point A. So at point A, we're going to do the same thing we just did. So potential energy equals mass, which is 3,000, times gravity, 9.8, and my height is now 33. So that answer comes out to be 970,200 joules. Now that's at point A, and I want to know how much did I lose to get to point C. So I'm going to subtract what I got up here. So minus 441,000. That means that 529,200 joules were lost from potential energy. Now, if you're losing it from potential energy, that means it went to kinetic energy. So you just found out what the kinetic energy was at that point, at point C. So on letter C, it says, what is the speed of the coaster at point C? So now I can use this, and I can set that equal to 1/2 mv squared. So 529,200 equals 1/2 my mass, which is 3,000. And v, I don't know, I'm going to leave it as v. So get V by itself, square root both sides, and I get a velocity of 18.8 meters per second. Okay, D, what is the speed of the coaster at point B? Its potential energy at point B. And would these numbers be the same for the second time the coaster passes this point? So what we're going to do is I'm going to figure out what the potential energy is at point B, so we can just go ahead and do that. So potential energy at point B, so PE equals mass times gravity times height. So 3,000 times 9.8 times height, which is 10, which is 294,000 joules. So I know there's part of my answer right there. Okay, so remember at point A, we found out our total joules was 970,200 joules. So that's before it actually starts going down and actually having velocity. So that means that is our total mechanical energy right there. Okay, so that means your total mechanical energy would be the same at every given point. So at point B, it would be 970,200. At point C, it's 970,200. So what I can do to find the kinetic energy at point B, okay, is I'm going to take that 970,200. I'm going to minus that 294,000 I just found. That means at point B, I have 676,200 joules of kinetic energy. Now, the reason why I found that is because I want to know the velocity at point B. And unless I know the kinetic energy, I cannot find that. So now I can do is I can set that 676,200 equal to 1/2 mv squared. So mass is still 3,000. And we're just looking for V. Okay, so this comes out to be 21.2 meters per second. Then the last question says, would the numbers be the same on the second time the coaster passes this point? Yes, it would. Okay, so remember, you start off with 970,200 joules every single time. Okay, if roller coasters worked differently, okay, that would kind of suck because if one time you make it on, you do go on the Titan, okay, at Six Flags, that means one time you'll make it through, second time you might not. You'll go down the hill, then go up the hill, but you won't make it and you'll come back down and you'll just sit at the bottom. So roller coasters are designed to be the same mechanical energy throughout. Okay, you have to have enough kinetic or enough potential energy, okay, to make it through the entire roller coaster. So whenever you come back through part B, A, or C, it's going to be the same every single time. Okay, so moving on to the next page, last one. We have a single roller coaster with a mass of 700 kilograms, holds 4 people on an average mass of 70 kilograms each. The roller coaster proceeds from point to point alphabetically. The entire track is frictionless except for I through J. So most of the time we don't have friction, so we don't have to worry about losing energy. The total mass of the roller coaster and its riders, so I'm going to take that 700 plus the average 4 people, so 4 times with the average of 70 kilograms. And that's going to come out to be 980 kilograms. Now, weight is just mass times gravity. Okay, so the force of weight, so I'm going to take that 980, I'm going to multiply it by 9.8. Okay, so that gives me 9,604 newtons of weight. 3, a chain hauls the coaster up from A to B. So basically what I'm doing is the beginning of the ride, you're going up to point B. So I want to know what the work done by the chain is. Okay, so remember work equals potential energy. Okay, I've got to get it up there to the top of the hill. So you can do work equals mass times gravity times distance since I'm lifting it up. So my mass, which is going to be 980, gravity is 9.8, and distance is 30 meters. Multiply all those out, and you get 288,120 joules. So at point B, you just figured out that the potential energy was 288,120 joules, which since I'm not going down yet, I'm not going to have a velocity at point B. That means kinetic energy equals 0 at point B, which means that potential energy is going to be equal to my mechanical energy. So now you know the total energy throughout the entire roller coaster. Okay, so you can always use that to kind of help you if you need it. So 4, the power needed by the electric motor to haul the coaster up. So remember, power is going to be work divided by time. So my work was 288,120 joules. My time was 30 seconds. It gave me it to, number 3. So divide that by 30. That's going to be 9,604 watts. 5, the potential energy at point B relative to the ground. Okay, so point B relative to the ground. So all I'm doing is what is the potential energy difference from here all the way to the ground right there. Okay, we already found that. It was 288,120 joules. Okay, so remember on 5, you're at the bottom. So you've got 0 joules of kinetic. So therefore all your potential energy at the bottom is 0. But at the top, it's going to be 288,120 joules. Number 6, the potential energy at F relative to the ground. So point F right here. So I've got 0 joules there because I have no height. So 0 joules. 7, the total mechanical energy at point D. So luckily we already found mechanical energy up there at point B. Okay, so that mechanical energy is not going to change. So it's going to be the exact same. So 288,120 joules. Okay, so remember, mechanical energy equals potential plus kinetic. 8, the speed of the roller coaster at point G. So point G, we do have height. Okay, so we're going to find out our potential energy. So potential energy is going to be mass times gravity times height. So I'm going to take that 980 times 9.8. And my height is 10 meters. So my potential energy is 96,040 joules at point G. So I want to know the speed of the roller coaster at point G. So what I'm going to do is I'm going to take that total I found. So 288,120 joules. I'm going to minus that potential energy. Okay, and that is going to give us 192,080 joules. That is now purely kinetic. Okay, so if it's not potential, it's kinetic. So what I can do is I'm going to set that equal to my equation. So 192,080 joules equals 1/2 my mass, 980, and V squared. I don't know V, so solve for V, and I get 19.8 meters per second. Okay, now I'm going to do the same thing with the speed of coaster at point H. So point H, what I'm going to do is I'm going to find what is my potential energy at point H. Okay, so potential energy is going to be my mass, which is 980, times gravity is 9.8, and my height, kind of ran out of room here, is 20. Okay, so multiply those out, and I get 192,080 joules. Okay, so now I'm going to do the same thing I did in part 8. So I'm going to take that 288,120 minus 192,080 joules of potential energy. That means I've got 96,040 joules of kinetic energy, which should make sense. If you're going up that loop, you're going to be slowing down. Okay, so potential is going to start going up, and your kinetic is going to start going down. So I'm going to set that equal to my equation. So 96,040 joules equals 1/2 my mass, which is 980, and V squared. So same thing as number 8. Okay, we're just doing it at a different height. Okay, so solve for V, and you get 14 meters per second. Now, the speed of the roller coaster at point F. At point F, you were at the bottom. That means your kinetic energy is all you have, which equals mechanical energy. And we know that our mechanical energy is 288,120 joules. So I can take that and just set it equal to my equation again. So I'm going to take that 288,120 equals 1/2 mv squared. Oops. Solve for V, and you get a speed of 24.2 meters per second. 11. If the final speed of the coaster at point J is 0 meters per second, how much friction is required to stop the coaster in 30 meters from I to J? So we're going to figure out how much friction is here to stop it. Well, I know that I have 288,120 joules of energy to stop. So remember, work equals force times distance. So I'm going to have to, that friction is going to have to overcome 288,120 joules of energy to stop. So we're going to set that equal to force times distance. Now, force we don't know, but distance we know is 30 meters. So divide 30 by both sides, and you get 9,604 newtons. 12, how does the speed of the coaster compare at points D, E, and G? So D, E, and G. If you notice, they're all at the same height. So that means your velocity better be the same. Since you didn't lose potential or gain kinetic, your heights are all the same. So that means your velocities will also be the same.